In the 1860s, many soldiers fought with weapons that moved at a human rhythm. Aim, fire, stop, reload, then do it again. Every shot demanded a pause, and every pause gave the battlefield time to change. Then came a strange machine with several barrels arranged around a central shaft. It looked almost too mechanical to belong beside rifles and muskets, yet by turning a simple hand crank, one operator could make it fire round after round in a continuous stream. No electricity, no gasoline engine, no modern automatic system hidden inside, just gears, gravity, rotating barrels, and timing. So how could a hand-cranked machine keep loading, firing, and ejecting bullets without stopping? To understand why that was so shocking, we first need to step back into the world before rapid fire. Let's get into it right here on Secrets of Simple Things. The slow world before rapid fire. Before machines like the Gatling gun appeared, firepower was limited by repetition. In the mid-1800s, many soldiers used single-shot firearms. These weapons could be powerful for their time, but they shared one major limitation. After every shot, the shooter had to reload manually. That meant the rhythm of combat was broken into small steps. Load the cartridge or powder. Prepare the weapon, aim, fire, stop, then start again. Even trained soldiers could only fire a limited number of rounds per minute because the weapon depended on human hands completing the same process over and over. On crowded battlefields, that slow rhythm mattered. It influenced how armies moved, how close formations had to be, and how much firepower a group of soldiers could produce. If a commander wanted more bullets in the air, the simplest answer was usually more soldiers, because each individual weapon could only work so fast. So the real problem was not only aiming, it was repetition. Load, fire, stop, load again. A continuous firing machine would have seemed almost impossible because it had to solve every step at once. It needed to load, fire, clear itself, and prepare for another shot before the whole process slowed down again. That was the problem Richard Gatling tried to solve, though his stated reason for solving it was more complicated than people might expect. Gatling's strange motivation. The inventor behind this machine was Richard Jordan Gatling, an American inventor with a mind for mechanical solutions. But his reason for developing the gun was not as simple as wanting to make battlefields more violent. Gatling believed that if one machine could produce the firepower of many soldiers, then armies might need fewer men on the field. And in the 1800s, that idea had a particular weight. Disease, infection, and poor medical conditions killed enormous numbers of soldiers, sometimes more than the fighting itself. Gatling hoped that reducing the number of people sent into war might also reduce the number of people who died from those conditions. Of course, history did not turn out so neatly. Whatever his intention, the invention still gave armies a powerful new way to concentrate fire at mechanical speed. That is the moral irony of the Gatling gun. A machine imagined partly as a way to reduce suffering became a symbol of industrialized firepower. This is why the story should not be told as simple praise. The mechanism was clever, but the consequences were not simple. Still, whatever Gatling hoped his invention would do, the reason it worked came down to one brilliantly simple idea. Stop making one barrel do everything. The simple idea: turn the gun into an assembly line. A traditional gun asks one barrel to repeat the same full cycle again and again. A cartridge has to be loaded, the shot has to be fired, the empty casing has to be removed. Then the whole process begins again. The barrel, the chamber, and the firing mechanism are all trapped in one repeated sequence. Gatling changed the rhythm by spreading the job across several barrels. He arranged them around a central shaft, like spokes around the hub of a wheel. When the operator turned a hand crank, the entire barrel cluster rotated together. But the clever part was not just that the barrels moved. It was that each position in the rotation had a different job. One barrel could be receiving a cartridge. Another could be ready to fire. Another could be moving through the part of the cycle where the empty casing was pulled out and ejected. Instead of waiting for one barrel to complete every step before the next shot could happen, the machine kept several steps moving at once. It worked like an assembly line. In a factory, one worker does not need to build the entire product alone. One station adds one part. Another station handles the next step. The process becomes faster because the work is divided. The Gatling gun was a hand-cranked assembly line, a rotating factory where every position had a job. Once you see it as an assembly line, the firing cycle becomes much easier to understand. The firing cycle: load, fire, eject, repeat. Now imagine watching one barrel as it travels around the circle. At the top of the gun sat a magazine or hopper filled with ammunition. In early versions, gravity helped do part of the work. Cartridges dropped downward toward the rotating mechanism, waiting for each barrel to pass beneath the feed area. As the operator turned the crank, the barrel cluster rotated. One barrel moved into position and received a cartridge. But the crank was not just spinning metal in a circle, it was coordinating the entire cycle. Inside the gun, a bolt moved back and forth along specially shaped tracks. These tracks acted like mechanical instructions. They controlled when the bolt moved forward, when it pushed the cartridge into place, when the firing moment arrived, and when the empty casing came back out. As the barrel continued through the rotation, the bolt pushed the cartridge into the chamber. A little farther along, the firing pin struck the primer at the base of the cartridge. The round fired. But the cycle did not stop there. The barrel kept rotating. As it moved past the firing point, the bolt drew the empty casing backward. Then the casing was ejected from the machine, clearing the way for the next round. By the time that same barrel returned to the top, it was ready to receive another cartridge and repeat the process. The important thing is that this was happening across all the barrels at once. One was loading, one was firing, one was ejecting, one was preparing to load again. The crank was not just turning the gun, it was telling every part when to move. But speed was only half the story. The rotating barrels solved another problem that every rapid-firing weapon runs into: heat. Why so many barrels? The heat problem. Every time a gun fires, heat builds inside the barrel. That may sound like a small detail, but it becomes a serious engineering problem when shots happen quickly. A single barrel can only handle so much heat. If too many rounds pass through it too quickly, the metal can become dangerously hot. Accuracy can suffer. Parts can wear down faster. In extreme cases, the weapon itself can be damaged. The problem is not only power, it is stress. Gatling's rotating design helped spread that stress across several barrels instead of forcing one barrel to absorb it all. Imagine a version with 6 barrels. During one complete rotation, each barrel fires only once. While one barrel is firing, the others are moving through the cycle. They are loading, ejecting, returning upward, and cooling slightly before their next shot. That does not make the heat disappear, but it distributes the heat more intelligently. The Gatling gun did not defeat heat by making one barrel stronger. It defeated heat by sharing the work. That is what makes the design feel elegant. It is not only a weapon story, it is an engineering story about dividing labor, reducing stress, and keeping a cycle moving. That sharing of work is what allowed the gun to reach a firing speed that seemed almost unreal in the 1800s. Speed without a modern motor. For people in the 1800s, this speed was difficult to imagine. Early Gatling guns could fire hundreds of rounds per minute, and later versions pushed that rate higher. Observers sometimes describe the sound less like separate shots and more like a continuous mechanical roar. But the surprising part is that the original Gatling gun was not automatic in the way modern weapons are. It was not using recoil to cycle the next round. It was not using expanding gas to drive the mechanism. There was no electric motor hidden inside the frame. Human power drove the whole system. The operator turned the crank, and the crank moved the barrels, bolts, and firing cycle together. Turn it faster, and the machine fired faster. Turn it more slowly, and the rhythm became more controlled. In that sense, the Gatling gun was both powerful and direct. Its speed came from human motion, translated through clever mechanical timing. It looked like the future, but it was still a hand-powered machine. And that is why the Gatling gun still feels fascinating today, not because it was complicated, but because its core idea was so clean. The legacy of a simple rotating idea. Gatling's design turned firing into a continuous rotating sequence. Multiple barrels divided the work. The crank synchronized loading, firing, and ejecting. The rotation helped manage heat, timing, and repetition at the same time. More than 150 years later, the same basic principle still echoes in some of the fastest firing weapons ever built. But the lesson is bigger than the weapon itself. When one part cannot do everything fast enough, divide the work and keep the cycle moving. The genius of the Gatling gun was not that it made one barrel faster, it made the whole process continuous. And sometimes, that is how simple engineering changes history, not by adding more complexity, but by arranging simple steps in the right order. If you enjoyed this look at the simple mechanism behind the Gatling gun, subscribe for more stories from The Secret of Simple Things. And if there is another object, machine, or forgotten idea you want us to explain next, share it in the comments.